Okay, in this video we are going to look at the very basics of projectile motion. You will learn a lot more about projectile motion in a class like physics, but in this class we're just going to kind of hit the basics. So first, let's talk about some of the definitions. First, we have speed. Speed is simply the distance traveled divided by time, right? So think about miles per hour. That's a distance divided by a time unit, or meters per second, same thing. Velocity, the way that differs from speed is it is the speed, but then also the direction. So you would want something like it's going 100 meters per second at an angle of this, right? You got to have a direction as well as just the speed, okay? And then acceleration is the change in velocity over a certain period of time. So if you think about the accelerator in your car, if you want to improve your speed, or if you want to go faster, what you're going to do is you're going to press the accelerator, which is causing your velocity to change over time. Gravity, we all know what gravity is. Whenever you are doing projectile motion calculations, you are often going to bring in gravity because here on Earth there is gravity. So a couple of constants that you will need to know: that the gravitational constant is negative 9.8 meters per second squared, or negative 32 feet per second squared. So it depends on which unit of distance we're using. If we're using meters or feet, that is the constant you will use for gravity. And that is the number that you would plug in for G. It is a negative because it's pulling whatever the object is downward. So we're going to use negatives to represent downward motion. So here's an example of a guy jumping out of an airplane. The acceleration is staying constant. Every second, his velocity is going to increase by 32 feet per second. So we're looking at it in terms of feet, not meters in this case. So when he initially jumps out, his velocity is 0 feet per second. He's just kind of, falling out of the plane. But then after 1 second, his velocity is now 32 feet per second. After 2 seconds, it's another 32 feet per second, so his velocity is 64 feet per second at that time. And then it's going to keep on increasing by a factor of 32 feet per second as he continues to get further and further down from the plane, right? So the gravity is continuing to pull him at that speed of 32 feet per second. Okay, so instead of skydiving, let's look at the human cannonball. And so what we're looking at here is a projectile being shot out of a cannon, and we're looking at that projectile would move at in a parabolic motion, right, like a parabola. And we're going to find some calculations for this where we can figure out things like horizontal distance traveled, initial velocity, launch angle, right? We can move this cannon to have it launch at different angles. But all the while, gravity is still pulling on that object. So even though we shoot it at some angle, the reason we get that parabolic motion is because gravity is working against it to bring it back down, right? If there were no gravity, whatever the object was would continue on a straight line that it is shot at, whatever that angle is, forever. So gravity helps us get back to the ground there. A variable that you're going to use when dealing with projectile motion, if you've never seen this before, is a Greek letter called theta. Theta is the variable most commonly used when the unknown is an angle. So our firing angle, we're going to use theta to represent that, and that is just, from the ground, what is this angle that the cannon is pointed at. The initial velocity, we're going to call that v of I. That's the way you say that, but it's just a subscript of I, which just means the initial velocity. If the angle is 90, this is just shooting this guy out of the cannon straight up into the air because this angle is 90 degrees. And it's showing kind of what would happen working against gravity. that he would basically go up and then come right back down if he were shot up with a speed that was to counteract the acceleration due to gravity. So here's an example just being shot straight across. He's trying to shoot him at this target. This is with gravity off. Obviously, he's just going to travel in a straight line right towards that target. And his distance is going to be constant at every second. If we turn gravity on, obviously we missed the mark because gravity is going to pull him down. The important part of this is the calculations. So we're going to look at a formula. It's the same formula every time. We're just going to kind of solve for different variables. So this would be the important part to write down in your notes, and I'm going to give you a couple of problems on your daily check over this formula. But then in addition to that, next time we'll be looking at a worksheet where we are to use this formula to help us find some things. So the formula relates these variables. V sub I, again, that's the initial velocity. So what is the velocity that we are being shot out of the cannon at? G is the gravitational acceleration, and I want you to notice that in the calculation it is negative G, but when you plug in for G, you're going to plug in that negative number. So you would plug in like negative 9.8 here if we're doing meters, or negative 32 if we're doing feet, which means this negative is basically going to cancel out the negative that you plug in, right? So that negative has to be there in order for this to turn into a positive value altogether. X is the horizontal distance traveled. So this length here would be a distance x. And then theta, again, is the firing angle. Sine is a trig function there. Hopefully you remember that from geometry or from trig. If the angle will probably most likely be given in degrees. So if you are using a calculator to do this, you do want to make sure that your calculator is in degree mode. It's usually in a settings on Desmos. It is in the upper right hand corner. There's a wrench. You can click that, and at the bottom of that screen you'll see either degrees or radians. You want to make sure that's in degree mode so that you can plug in the angle there. So this is that formula that is solved for initial velocity. So if I was concerned about what was the initial velocity that something was shot out of a cannon, I have my formula over here. It's just the square root of negative the gravitational acceleration times the horizontal distance divided by the sine of twice the launch angle. The next two slides are just going to be this formula solved for a different variable. So if I wanted to solve it for horizontal distance, this is what that formula looks like. It is simply just the initial velocity squared times the sine of 2 theta divided by negative gravitational acceleration. Again, that's just simply if you took this formula and you solved for x, and you did a little bit of algebra there, that's what you would end up with. And then again, I'm going to do this, but solve for theta. And if I were to solve this for theta, now it has 2 theta on this side. I would actually go ahead and just solve it for theta. So what I would do is either divide all of this by 2, or I would just put a multiplier of 1/2 out front. So 1/2 theta would be equal. Theta would be equal to 1/2 times the inverse sine of this. Now inverse sine, you would want to use a graphing calculator for that. Inverse sine means, hey, this is the angle that's going to give me a sine value of whatever this is in here, right? So anytime that you use inverse trig, you're solving for an angle. Okay, so that is it, and we are going to use those formulas to help us with some pretty basic projectile motion calculations. If you are given all these variables except for one, you should be able to solve for that variable using whichever iteration of that formula you need.